In this section, we're doing problems that involve using the chain rule. First problem, given y is equal to 3x plus 5 to the 17th power, we need to find dy dx. So let's let u equal 3x plus 5, and then y is equal to u to the 17th power. So then we need to find dy dx is dy du times du dx. So dy du is 17u to the 16th power, and du dx is just 3. So therefore, dy dx is dy du times du dx. dy du is 17u to the 16th power, and then we're going to multiply that by 3. So that gives us 51u to the 16th power. But we need to change u back to our original definition of u. So we now get that dy dx is 51 times 3x plus 5 to the 16th power. Okay, next problem. Given y is the sine of x squared plus 3, find dy dx. Okay, so again, we're going to let u be the thing inside, so that's x squared plus 3, and we're going to let y be the sine of u. Now we already know that we need dy du, and we need du dx. So dy du, the derivative of y with respect to u, and that's just cosine u. And du dx is the derivative of u with respect to x, and that's just 2x. So therefore, dy dx is dy du times du dx. dy du is cosine u times du dx is 2x. So this is 2x times the cosine of u. But once again, can't leave the problem. We have to take it back to its original state. So therefore, we get dy dx is equal to the 2x times the cosine of x squared plus 3. Now, by now, you might be able to have figured out that we're differentiating the outside function and then the inside function. So what we just did before was the inside-outside rule. So now what we want to do is the outside-inside rule. That is, we're going to keep differentiating until we can't differentiate anymore. So say we have y is equal to 1 plus the tangent of 3x to the 4th power. So our outside function, as you can see, is something to the fourth power. So what we'll do is we will get dy dx says differentiate that outside function. So you're going to bring this 4 down and then decrease that by 1. So you're going to get 4 times 1 plus the tangent of 3x cubed. So now we've taken the derivative of the outside function. So now we have to take the derivative of the inside function. And the derivative of the inside function, well, that's the derivative with respect to x of 1 plus the tangent of 3x. So now we get dy dx is 4 times 1 plus the tangent of 3x cubed. And now we need to take the derivative of this quantity. And the derivative of the tangent is the secant squared of 3x, because the derivative of 1 is 0. So now we've taken the derivative of that, but we still have to take the derivative of the inside of the tangent function. So therefore, we're going to multiply by a 3. So now we get that dy dx, this 3 times this 2, give me 12, times 1 plus the tangent of 3x cubed, and then I still get the secant squared of 3x, and I am now completed the problem. Next problem, we have y is equal to 2 divided by x minus 1 to the 5th power. So as we can see, our outside function is something to the 5th. So we're going to do this problem 2 different ways. Okay, so the first way is we're going to do it the inside-outside way. So we're going to let u equal 2 over x minus 1. And then we're going to let y equal u to the 5th. So now we need dy du. So that's 5u to the 4th. And now we need du dx, which is to take the bottom times the derivative of the top, which is 0, minus the top, which is 2, times the derivative of the bottom, which is 1, all over the bottom squared, which is x minus 1 squared. So now we get du dx is negative 2 over x minus 1 quantity squared. So therefore, dy dx is dy du times du dx So now we're just going to get minus 10 over x minus 1 quantity squared. But we're going to multiply this by u to the 4th, and u was 2 over x minus 1 to the 4th power. So this looks like minus 5 times 32. Two to the 5th is 32. This is to the 4th power. There's a silent 4 here because both terms get multiplied to the 4th power. And then we have 2 here, so this becomes to the 6. Okay. We're good. Okay, the other way is to do it the outside-inside way. And that is we have y is equal to 2 over x minus 1 to the 5th power. So therefore dy dx. Bring down that 5 times that whole thing raised to the 4th power because you're differentiating it. And then you need to multiply the derivative with respect to x of 2 over x minus 1. Now we found that in the last problem here when we did this piece. So we know that the derivative of that thing, so we get 5 times 2 over x minus 1 to the 4th power, and we're going to get minus 2 over x minus 1 quantity squared. And that still gives us negative 5 times 32 over x minus 1 quantity squared. And this is just minus 160 divided by x minus 1 quantity squared. Okay. Here's another one that's going to involve the chain rule. And that is the derivative. So y is going to equal 2x plus 1 to the 4th power divided by 1 plus x squared. So as you can see, we have a quotient rule and a chain rule. So let's find dy dx. So we're going to get y is the bottom, 1 plus x squared, times the derivative to the top. The derivative top involves a chain rule, so that's going to give me 4 times 2x plus 1 to the 3rd power, but I have to still differentiate what's inside here. So I'm going to multiply by a 2 minus the top, which is 2x plus 1 to the 4th power times the derivative of the bottom, which is 2x. Take that whole thing over 1 plus x squared. So let's see what we can factor out. This is y prime. So let's see what we can factor out. So in the numerator, I have for sure a 2x plus 1 cubed. So that'll take care of that term. And each term also has a 2, so let me pull that out. And that's going to leave me, well, I took out 2x plus 1 cubed. I took out the 2, so that's going to leave me a 4 times 1 plus x squared. And in the second part, I took out 2x plus 1 cubed, so I still have 1. And I took out the 2, so it still leaves an x. Okay, we're still simplifying. So y prime is 2 times 2x plus 1 cubed. And inside here, I'm going to get 4 plus 4x squared. Then I'm going to subtract off 2x squared. And then I'm going to subtract off x. I have to distribute the negative over both terms. So they both will be negative, 2x squared minus x. And this is all over 1 plus x squared squared. So now we have y prime is 2 times 2x plus 1 cubed. And in here, I'm going to get 2x squared minus 2x squared. It's going to give me 2x squared minus x plus 4 divided by 1 plus x squared squared.